In this problem, we want to find the area that is enclosed between these two, kind of by these two curves. So to start, let's just have a very rough sketch of these two. So here we have a y equal to negative x squared plus 6x minus 2, which is a quadratic function. And because it has a negative coefficient for x squared, it's kind of downward, it's concave down. So we have a function like this. Again, it really doesn't matter if it's accurate or not. And this one is a function which is a linear function. It's x to the power of 1, and the coefficient of x is just a positive number. It's just 1, which means it's a increasing line like this. So what we expect is the enclosed area be this part. So to find that, we need to kind of finding the area under the curve or between curves, we need to take the integral. But what are the bounds of the integral? The bounds of the integral would be the intersection of these two functions. So let's call this one a and b. So we want to basically take the integral from a to b of these kind of functions basically. So the first step would be finding the intersection points. Find intersection points, we set the two functions equal to each other. So what I do, I just write negative x squared plus 6x minus 2 is equal to x plus 2. So I can just move everything to the right hand side. And the reason that I move these terms to the right hand side is I make the coefficient of x squared positive. So it's a little bit easier for me to build that. It would be x squared, it's negative, so it goes to the other side, becomes positive. Positive 6x, it becomes negative 6x, and this goes to the other side and becomes positive 2. And already we have positive x and positive 2 on the right hand side. So nothing is left on the left hand side, so we have 0. So from here, we can say 0 is equal to x squared minus 6x plus x. Overall, it would be minus 5x. And plus 2 overall plus 4. Now we can simply factor the right hand side. So 0 is equal to, so we are looking for two numbers which their summation is negative 5 and their multiplication is positive 4. So the two numbers can be negative 4 and negative 1. So I can write an x minus 4, x minus 1. So here I can see that x equal to 4 makes this equation correct, kind of true. So both sides would be 0, and x equal to 1 also makes this bracket 0, which means this side would be 0. So the roots of this equation, our original equation which was here, are 4 and 1, which are basically the 2 points that are these functions are intersecting with each other. Again, this graph is not precise and it really doesn't matter. So what we know is the first point is 1 and the second point is 4. Now what we need to do is simply take the integral of the upper function minus the lower function. So I just write the upper function minus the lower function and dx from 1 to 4, from the starting point to the ending point. And here we know the upper function is negative x squared plus 6x minus 2. So it would be simply integral from 1 to 4, negative x squared plus 6x minus 2. This is the upper function minus the lower function, which is just x plus 2. So this is the lower function. This is a linear function. But if you couldn't decide, you couldn't kind of get it correctly that which one is the upper function, which one is the lower function, basically for this region, I know that at these parts, the upper one would be the blue one, but we don't care about this region. What matters is the area bounded, which means this part only. If you couldn't decide which one is the upper one, which one is the lower one, really does not matter. So just one of them minus the other one. If you choose them wrongly, incorrectly, your final answer would be negative. But at the end, you know, the area between anything, just area generally, is supposed to be a positive value. So at the end, if you got a negative number, just simply take absolute value of that and make that a positive number. So really doesn't matter if I write this minus this or this one minus this. At the end, I will make my final answer positive. So to take this integral, I can take the integral of this separately, this one separately, or I can just simplify it. First, let's just simplify it. From 1 to 4, I have negative x squared. I have positive 6x and minus x here, which makes it positive 5x. And I have minus 2 and minus another 2 here, which makes it minus 4d. Taking this integral should be very simple. This is just a power rule, which it gives me negative x to the power of 3 over 3 plus 5x, which the 5 is constant, so I just simply write that, and the integral of x would be x squared over 2. And the last part, just negative 4, which it would be negative 4x. This is the antiderivative or integral of that function, but it's a definite integral. We have bounds, so we plug in the upper bound and the lower bound. So first we plug in the upper bound here. So what we get is negative 4 to the power of 3 over 3 plus 5 times 4 to the power of 2 over 2 minus 4 times 4. So I just plug in 4 for all the x's that I have here. And I do the same with 1. And I subtract when I plug in the lower bound. It would be negative 1 to the power of 3 over 3 plus 5, 1 to the power of 2 over 2 minus 4 times 1. Now here we get, we can just simply evaluate that. Negative 4 to the power of 3 is negative 64 over 3 plus 4 squared is 16 divided by 2, it's 8, and 8 times 5 is 40 minus 4 times 4, which is 16. This is the first bracket minus the second bracket, which would be negative 1/3. 1 to the power of 3 or 1 to any power would be just 1 plus 1 squared is 1, 1 over 2 is 1 over 2, and times 5 it's 5 over 2 minus 4 times 1, which is simply 4. Let me just rewrite everything here without any brackets. Okay, so the first part would be as is, negative 64 over 3 plus 40 minus 16, and I simply need to distribute this negative sign into the bracket. The negative times the first term would be positive 1/3. Negative times this part would be negative 5 over 2, and the last term would be positive 4. So here, what we can do, we can just add this one with what we have here. Negative 64 over 3 plus 1 over 3. This is negative, this is positive. Overall, it would be negative 63 over 3. Plus, we have 40 minus 16, which is 24. And we have another 4 here, which makes it 28. Positive 28. And we also have this negative 5 over 2. Negative 63 over 3 can be simplified to negative 21 plus 28 minus 5 over 2. And again, negative 21 plus 28 is simply 7 minus 5 over 2. The common denominator is 2. We can write that as, instead of 7, we can write it as 14 over 2. And this would be just 5 over 2, so minus 5. So overall, it would be 9 over 2. This would be, it's already a positive number. And again, if you just swap these two, and you couldn't tell which one is the upper function, which one is the lower function, this number would be negative 9 over 2. At the end, we would make it a positive number. So what matters the most is finding these 2 points, the bounds of the integral, or where the functions are intersecting with each other. So this would be basically the area bounded by those two functions.